Alrighty, we're going to start by reviewing factoring because you guys sucked at it. So factoring, who can remind us what it means? If I want to factor that, what does it mean if I'm factoring out all the common stuff? Dan?
You're turning it into
What? Okay, Vincent. I'm essentially taking out everything that's common. So he's saying I could divide everything by 2. So if I'm pulling out a 2, I'm thinking, okay, what's essentially going to be left over? There's still going to be a 2 left over, a 2xy, and a y. Okay. So I could factor out that 2. Is there anything else I can factor out? Anything else that both terms have?
the y.
The y. So I could also factor out a y, essentially dividing everything by a y and seeing what's left. So I still have a 2x left, and I still have, well, essentially a 1 left. So thoroughly factoring, I'm taking everything out. Some of you were just getting to this step on your quiz and only factoring out one thing, but you want to factor out everything that's common.
But what's the point of that?
What?
Like, what's the point of this? How does it help?
There's things later on where you essentially can solve for x by factoring, because then you can have something a little bit more simple opposed to something more complicated. This will help when you're getting to something more complicated and you're trying to solve for x. So you'll actually end up factoring it into 2 things. That's probably not actually right, but you're going to be factoring it into more simple things so you can actually solve.
Are we able to see what grades we have in our class?
Your grades have been on haiku for the last week, and you'll get your quizzes back at the end of class.
Oh,
okay. Oh, that does not erase well. Let's do one more review of factoring. Let me think of something.
Don't know what I did.
Okay, go ahead and factor that one. Yeah. Let's go ahead and factor out everything that's common between both of those terms. Haley?
B.
There's a b that we could factor out. So 16a plus 4, and then we still have one more b. Anything else we can factor out? Isaac? A 4 also, because if I divide everything by 4, so 4b, I have a 4, an a, and a b. So this, I mean, yes, you're factoring out something that's common, but thoroughly factoring would be down here. Okay, so you'll miss the quiz and you'll have to make it up next week.
Right.
Yes.
Would the square just attach onto the B?
Yes, because that square means that there's 2 b's, so we're essentially taking one of them out. Any other questions on factoring? Yeah.
So you just divide these out?
Yeah, we're dividing the b's out here. So that's how you end up with just 16a, and then you end up with 1b. Because there was 2, we divided out 1. Yeah.
If that was 4B cubed, then would it be B squared at the bottom?
Yes. Yeah, if it was 4b cubed and we factored out a b, then we'd still have 2 left over.
No.
Good question. Anything else on factoring? Yeah.
So it's essentially taking 2 a B away. Like if it would be 4, would you take 2 or just 1 out?
It depends on what you're trying to do. So if we had 4 b's, if you want to take 2 out, you'd still have 2 inside. But if you wanted to take 1 out, you still have 3 inside.
It depends what you want.
It depends on what you're trying to take out. And that's why math can be confusing sometimes because it really is. You just need to figure out what your end goal is and then work towards that.
Could you do like another set of parentheses outside, like B and then parentheses and then B another set of parentheses?
Yeah, so if you wanted to turn this into B parentheses B parentheses B squared, yeah. I mean, that's the same thing, right?
I know, I just like.
If you want to make it all confusing. Alrighty. So now let's actually dive into the stuff we're doing today. Is that dry enough? No, that's not dry enough. So how do you guys like fractions? No? Okay. Then you'll hate this.
No. Oh wait.
So we're going to start with the basics. Help you remember just what we even do with fractions. So when I'm adding fractions, what has to happen with the denominators? Mimi? We have to have the least common denominator. We need to have a shared denominator so we can actually add these. So if I want a shared denominator between 5 and 3, what can I use?
15.
15. So how do I turn 4/5 into having a denominator of 15?
Since you're multiplying 5 by 3 to get 15, you do the same thing to the top.
We do the same thing top and bottom. So I'm going to be multiplying top and bottom by 3 over 3. So that's going to get me my 12.
And they do also
Mhm.
multiply the 3 and the 1 by the 5.
By 5 over 5 for over here. Yes.
Would you just cross multiply on the top?
No, because we're not multiplying.
Oh.
We're adding. So we need to have a common denominator.
Oh.
So to get my common denominator, I need to multiply top and bottom by something in order to get an equivalent fraction. Now that I have my common denominator, now what do? Isaac. We add the numerators. What happens to the denominator? Stays the same. Of course, and then you can simplify and blah, blah, blah. Okay, can I erase this?
Yeah.
Okay. So, we are going to be looking at adding fractions that have expressions in the denominator. So instead of just having like 5 as your denominator, it could be like x plus 2. Or c squared plus 5 as your denominator. Dan? Okay. Bless you.
Thank you.
All right, so let's actually start fairly simple. So let's just start by throwing some letters in. So I had 2 over x plus 3 over y. So make sure you check Haiku to see what your grade was from last week. So if I'm going to add these, what needs to happen with the denominators? They need to be the same denominator. So what could be a shared denominator between x and y? Mimi. X, y. Why not? Just multiply them together. That's what we actually normally do. So we want a common denominator of x times y.
Oh, hi. I'm Debbie at my house. Hi. I'm sorry I'm not interrupting. Friday's is lacrosse now. Okay.
So you can just watch the videos online.
You know where they are? Does it?
Yeah, they're
on video. Oh, okay. Thank you so much.
All right, so if I want to have the denominator of xy, how can I change x to be xy? What do I need to multiply by? Caitlin?
Y.
Y. I'm going to multiply top and bottom by y.
Oh,
So it's the same thing we were just doing before, now with a variable.
yes. It'll be 2y.
So it'd be 2y on top. What about this y, this 3 over y? How do I get to be a denominator of x? Times it by x over x. So what's my numerator?
3x.
3x. Riley?
Would it be 5? Y?
Are those like terms?
Oh, no.
No, they're not. So we can't actually combine them. So the way it will look, it would be a 2y plus 3x over that shared denominator. And then you'd be done, because there's nothing you can simplify from there. How does this thing seem?
Easy.
Not too bad? You ready to kick it up a notch?
Yep.
Okay, make sure you're asking questions if you have them. So now let's actually have a true expression in a denominator. Everything we do doesn't change. It's all the same thing. All right, what's a shared denominator we can have? Dan?
X, y plus 3.
Mm-hmm. X times a y plus 3 and an x times a y plus 3. Really as simple as just that. Multiply them together. We don't even need to distribute. We can leave it like that. So how do I get from an x to an x times a y plus 3? Ian?
What's going on?
How do I get from an x to an x times y plus 3? Times top and bottom by y plus 3. So that'd be 4 times our y plus 3 on top.
We could,
And we can distribute it, so if we want to do that here, 4y plus 12 over our x, y plus 3. What about over here? How do I get from the y plus 3 to an x times y plus 3? Yeah? Not divide by x, multiply by x. Top and bottom times x, so we get that 2x. Now in this case, distributing it out won't actually change much, but some cases it'd be good to distribute that out because there might be things to combine with both of them. So now we can just add across the top, keep the same denominator. And you have your 4y plus 12 plus 2x. In high school, they'll expect you to know that your order of having things is always alphabetical, so x should come before y, and stuff without variables goes at the end.
Why?
Oh, shoot. It's just the proper way of writing things. Just how things go. So technically this is not wrong, but this is the proper form that they'll expect in high school. And depending on your teacher, they might accept this or they might not. How we feel with this? Kind of okay?
Yes.
Ready to kick it up another notch?
Yes.
Okay. Let's do that. So what if both of the denominators have expressions? It's still the same thing. It'll look a little nastier at the end, but it's the same process. Right.
With
Okay.
x minus 1 and x plus 1, would they cancel each other out afterwards?
Nope. So what's a common denominator that I can use between both of these? Last time we just multiplied the denominators together. Isaac? Right. So I'm thinking that my common denominator is just both of them multiplied by each other. So as nasty as it looks, that's what it is, because we're just multiplying them by each other. We don't even need to distribute anything or all that. We can just leave it like that. So how do I get from x minus 1 to x minus 1 times x plus 1? Isaac. Multiply top and bottom by x plus 1. So that'll be your 2 times that x plus 1. Then how do I go from x plus 1 to x minus 1 times x plus 1? Caitlin.
You added x minus 1. You
Multiply x minus 1 by x minus 1. So that would be 5x minus 1. So now we can look at distributing the top, because that will help it so that when we add later we can actually combine the like terms. So let's distribute this 2. So we have our 2x plus 2 over that x minus 1 and x plus 1. Same thing with the 5. distribute out this 5. So now I get to the point where I actually can add across the top. So we can either just look at it and add it, or if we kind of want to combine them and then combine like terms later, we can. So if we want to just kind of throw everything together and then kind of simplify it later, we can do this. But some of you can see what we need to combine together at the blue stage. So what like terms can I combine at the top? Mimi.
X.
The x's. So 2x plus 5x.
7x.
7x. Anything else? Riley.
Just the base number.
Yeah, the 2 and the minus 5, that's negative 3. And we still have all this stuff at the bottom. And there you go. You guys ready to try some on your own?
Yes.
Yeah? Okay. Yeah, of course. Alright, let me think. Go ahead and do that one. And go ahead and do those two.
Yeah, it's all essentially one expression, so it's just say together. I would keep the b squared plus 2 in parentheses. it so you're distributing it to that term, so it becomes 5b squared. B squared. 2 more minutes. You're done. Compare with the people at your table. There's something to solve. You can put together over 1. Yes. When it's negative, you don't need to do
So it'd be 6.
what did you see?
5 and 2. What did we get? This one. We have to.
For the first one,
What?
yeah, it's the first one.
So it has the same thing, but it's in different order.
That's probably fine then if it's in a different order.
Okay.
Let's see.
No, I got this
I got the same thing.
If your order of terms is a little different, it's fine as long as you kept any negatives with negatives and positives with positives. Isaac? No, because none of these are like terms. They're all different terms. So you can't combine any of them, so it just has to stay like that.
it's just like it's right, but I don't know if you could do that. Just like parentheses. I think it's the same.
Yeah. The order really doesn't matter. Any questions about this? How I got to where I got?
Still on the second.
Ryan and Diego, if you guys can't take it seriously, you'll be asked to leave. All right, can I erase this?
No.
No? Okay.
Erase the first one. Just the first one.
Okay. All right, if you have a calculator, please take it out. You're gonna want it for this next part. Are you guys done with the second part? Almost. Okay. All right. Next, we're gonna be looking at converting units. So essentially going from like miles to centimeters or seconds to hours. I know you guys learned this probably back in like 4th-ish grade, but I'm gonna show you a way so that you can always make sure you're dividing when you're supposed to be dividing or multiplying when you're supposed to be multiplying, and making sure you're getting to the right units. Can I erase?
Yeah.
Okay. Alrighty, let me think of a really big number. Let's start with 1 billion. These are different. We're gonna start with 1 billion seconds. It is a lot of seconds, but how many years is that? So I'm gonna go from seconds to years. So obviously there's no one conversion straight to years. What's an in-between step? What can I convert seconds into that will get me closer to years? Sophia? Minutes would be good. I know how to convert seconds to minutes. So what goes to what? How many, is it minutes per second or is it second per minute? What's the conversion for seconds and minutes? Dan? Well, no, just like what? How many seconds is 1 minute?
60.
Awesome. Okay. Now I know I put it the right way because seconds are going to cancel out with seconds from top and bottom, leaving behind minutes at the top. So that's how I know that I'm going to need to be dividing, because seconds need to cancel out with seconds, leaving minutes at the top. All right. So we're at minutes now. What's something else that can get me closer to years? Hours. Okay. So how many minutes per hour? 60. Really hope you all know that. Especially since there's an entire TV show called 60 Minutes. So now the minutes are going to cancel out. I have hours left at the top. So what do I want to convert hours to? Days. So 1 day is 24 hours, approximately. And then, so we're at days because hours are going to cancel out. What do I want to go from now? Days to We don't know days to year? No one
Yeah,
knows?
years.
Oh.
There's 365
There we go.
There is?
Yeah, how do you know that?
I remember.
What about this year?
Disney
It's
Channel, they go
366 this year.
365.
We're talking about non-leap years. Since it happens 3 out of the 4 times. Because leap year's every 4 years.
And it's this year too.
No, it's four.
And it is this year. Okay, so
We're February and 29.
opposed to, stay with me, I know this is very exciting. Opposed to blindly trying to figure out, wait, do I divide, do I multiply? The way you line it up is you want your units to essentially cancel each other out until you're left with what you want. So just remember, if I have something over something, that equals 1. That's why those top and bottoms cancel out. So in the same way, seconds will cancel out with seconds, minutes will cancel out with minutes, hours will cancel out with hours, days cancel out with days, and that means the units I'm left with is years, which is what I'm going for. So that's how you know if it should be top or bottom. Okay. Let's go through this again slowly.
Oh, I see. Because year's the only one without mesh.
Because year's the only thing that doesn't have anything to cancel it out.
No? Yeah.
Okay?
Okay.
So seconds are canceling out with seconds because you have it top and bottom. So they end up being 1. Minutes cancel out with minutes because it's top and bottom and it ends up being 1. Hours cancel out hours, the days cancel out days, and years is the only thing left over. So that means when we're all said and done, the units we're left with is years, and that's what we want. So that's how we know that we lined up everything correctly. Because I see this sort of thing all the time when people are like, okay, that pen doesn't work. They're like, well, orange is just not a good color. So if they're trying to go from like seconds to minutes, and so they're like, well, 60 seconds and 1 minute, and they try to multiply them. This is how you catch your mistake because you're like, wait, seconds won't cancel out, so I'm doing the wrong thing. So this will how you'll catch yourself instead of when you're supposed to be multiplying or dividing and stuff like that. So grab your trusty calculators and go ahead and do 1 billion divided by 60, divided by 60, divided by 24, divided by 365. You don't own a What about your laptop? You're going to want it for the quiz. Then you must hate it all the time. Let's go. You all have calculators. You have your laptops. You're going to want them for the quiz, so get them out. Divide. Divide 1 billion by 60, then divide that by 60, then divide that by 24, then divide that by 365. Haley, get out your calculator.
I don't have one.
Where's your laptop?
Wait, what do you use 60?
So 1 billion divided by 60, divided by 60, divided by 24, divided by 365. Mimi.
31.70.
31.
7919.
31.
So we're all getting about 31.7.
31.7 years. So when you're almost 32 years old.
So this means,
If somebody asks, you'd be like, I am.
so I'm actually not even 1 billion seconds year old yet. I'm actually still far from that.
That's cool. You're really young.
I am really young.
Why do people divide it with like 60?
So we're dividing because we want to get smaller. Because we started with a unit that was really small, so we had a lot of them. But we were essentially consolidating them into, okay, we're going to take these 60 of them and put them into minutes, and then we convert it to hours, and then we convert it to days. So it makes sense that our number's getting smaller. So that's always another good way to figure out if you were dividing or multiplying correctly is if your number makes sense. Getting that into 31 years makes sense because it's a smaller number. You'd expect seconds to go smaller to get to years. You guys ready for another one? Okay, can I erase this?
Yeah.
Okay. We're gonna start with a mile. We're gonna start with a mile, what you guys run pretty regularly in PE. And we're gonna convert this to inches. So that the next time you guys are running the mile, you can be like, oh my god, I'm running blah 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 inches. So, what can I convert miles into that would get me closer to inches? Dan? Feet?
Yards.
Meters?
Well, do you guys know those conversions off the top of your head?
No.
Centimeters.
Someone look up how many feet in a mile. I actually used to remember it, but because of my dyslexia, I always get it wrong. 2,000? Exactly that. 5,280?
No, it's 2,500.
That doesn't sound
5,280.
exactly.
5,280 exactly.
Okay. Cool. Alrighty, we'll go with that.
That was
Okay. So we know we're doing it correctly. We know that we have it lined up because the miles are going to cancel out with the miles, and we're left with the feet.
It's per feet a month.
So right now we have, yeah, that's how many feet per mile. What can I change feet into that will get me closer to inches?
Oh. Otherwise.
We can just convert it to inches, right? We know how many inches in a foot, right? 12. Come on, guys. Second graders know this stuff. And I know I have them in the correct order because feet are going to cancel out with feet.
Oh yeah. Oh, you put that in the next one on top this time.
The big numbers are on top this time. See, this is why I like lining it up like this because you can tell I am doing it correctly. And it makes sense that my number is going to get bigger because I'm going from a big number and breaking it up smaller. So I should have more pieces at the end. So it makes sense that, of course, there's going to be a really big number. So to tell if I'm lining up everything correctly, mile will cancel out with mile, feet will cancel out with feet, and I have inches left. So someone needs to do 5,280 times 12. This one's a little bit simpler.
6,300.
One person slower.
63,360. 6,000.
Let's just run through 63,360.
Okay. Okay. So we know we did it correctly because all the units canceled out, leaving behind the unit I want, which was inches, and it went from a small number to a big number, which makes sense because we went from a big unit of measurement to a little unit of measurement.
I have a question. Why
Okay.
did we divide on the first one and multiply on the second?
So we divided on the first one because we started with small units and we went to big units. This time we started with big units and went to small units. See, and that's why I like to do it where I just line up where the units go instead of having to figure out, wait, do I want to divide? Do I want to multiply? What am I doing right now? It just works to line up the units. Okay, questions about unit of measurement and converting them and whatever? Okay, then we're going to move on. We're going to move on to more fractions. These ones I like because they freak people out, but they're not hard. So these are called complex fractions, but complex just talks about how they're in order, but they're actually not complex. I think they're rather simple, but they tend to freak people out. Yes.
Is just fractions and fractions?
Yes. So if I have the fraction 4 over 5, what's actually going on between those numbers? What operation is going on, Robert?
4 is being divided by 5.
Exactly. This is 4 divided by 5. So don't forget what fractions actually means. It means division. We just are too lazy to do the actual division, so we put it in fraction form. So you can have fractions divided by fractions. We all know this. Most of the time we see it as like 1/2 divided by a 4th or something like that. But there's another way to write it. You can put it as 1/2 divided by a 4th. That's a complex fraction, but it means exactly the same thing. They're exactly the same thing. Just in a weird form that always freaks people out.
That's weird because it's like a
Isn't that weird?
fraction. I don't know, it just
So
looks
there's
weird.
0.8 and there's 0.25.
What do you mean?
Not yet. I'm going to show you something first that my 7th grade teacher taught me.
What do you point?
Well, 4 divided by 5 is 0.8.
Oh, you're talking about that one over there.
Okay. How do you normally divide fractions, Vincent?
You put the second one
And
and
Multiply.
so normally we would do times 4 over 1, which is 4 over 2, equals 2. So you, of course, whenever you see complex fractions, can always turn it into a normal way fraction and just do it this way. But I'm going to show you a trick that I like. That's much faster. That will get you to here. There's probably a complex name for this. I call it outside, outside, inside, inside.
How do you call it? 2 out, 2 in.
Just let it fall down.
Because it tells you what you do.
O squared, I squared. Outside squared, inside squared.
Not even that complicated. So what we're going to do is we're going to do outside times outside. So that's 1 times 4, which is 4.
Oh, so
Over inside times inside, which was 2.
Oh,
Look at that.
so cross multiplying.
So we went through all of these steps straight to here by doing outside times outside, putting it on top of inside times inside.
So it's like a sideways way.
Yeah.
Wait, what do you mean outside?
These are on the outside,
Oh,
these are on the inside. And you're going to multiply them. So 1 times the 4 gives us the top. 2 times the 1 gives us the 2. And then you can reduce and all that junk. Alright. You guys think you can try a couple? Let me think of one. Go ahead and try that one. 2 over 5 divided by 1 over 7.
Wait, we just do outside, outside.
Outside times outside over inside times inside.
I'm using the side feet.
Alright. Jack, what do I do here?
Outside, outside, inside, inside.
So I do
Outside.
2 times 7 over
5.
5 times 1, so I get 14 over 5.
Too high.
In high school, they want you to reduce it or no?
That all depends, reducing it is all dependent on what you're doing with it. So as we've seen in slopes, it's actually easier to work with it when it's like that. It really just depends on what you're doing with it, and a lot of times in the instructions it'll say leave in fraction form, leave as a decimal to 1 decimal place, or blah blah blah. Each teacher has their own preference. Mimi.
So we're basically cross multiplying simple dividing.
Yes. You are cross multiplying essentially because it's the whole flip thing and blah blah blah. But you're skipping all of that because you're doing outside, outside, inside, inside.
I call it the double rainbow.
All right,
The double rainbow.
time to scare you guys. Ooh yeah.
But 1 over 1 and then divide by 1. 2.
Oh, it's kind of scary. That looks ugly.
Hey, remember, you are always welcome to actually separate it into the fractions, flip it, and multiply. I still think it's easier to do outside, outside, inside, inside. So if I do outside times outside, who can tell me what I get? Y minus 1, because it's just 1 times that stuff. Okay. If I do inside times inside.
X2. And then 2x plus 1. Yeah.
Sure, we can leave it like that. Okay. So you can see it's the same. Even when they start throwing really weird things at you, it's going to be the same thing. Yes.
Could the x squared times x plus 1, could that be x cubed times plus
Yeah, you can distribute that out. So you can make it x cubed plus x squared and y minus 1. It all depends on like what they're asking for. If they're saying simplify this is fine. Because this is not technically more simple than that, and this is technically not more simple than this. It's all kind of what you're leading towards. So if you see this, it's probably okay just to leave it like this. Questions? Or is this okay?
It's okay.
It's okay? It's not so scary? Alright. Alright. Alright, shh. Stay with me. I want to get you out of here on time. Alright. This is a little bit more complex. There's actually something we need to do before we can even do outside, outside, inside, inside. Make the top one an actual true fraction and make the bottom one a true fraction, just like we saw earlier on. So if I want to change 4 plus 1 over x into being just another fraction, what's the denominator I'm going to want between 4 and 1 over x? 1?
X2.
X2? Just this top one. If I'm combining those, what do I want to do? Ian?
Or you want to give it a common denominator.
So what's my common denominator?
It will be x.
We could just leave it as x, yeah. Because then that'll be 4x. Because I'm going to have to multiply top and bottom by x. And this guy stays as 1.
Wait, why would it be x?
Because 4 over 1, it's just 1 at the denominator, and common denominator is going to be x. Okay? So now we also need to combine the bottom ones. What's a common denominator for the bottom ones? X squared, x2. Okay? So I'm going to need to change this 3 to be top and bottom x squared. So that'll be 3x squared plus 2. So now it's in a form that we could do outside, outside, inside, inside. But I'll pause and let you guys catch up. All right. If I do outside times outside, who can tell me what we get?
You will get
Oh, it's X.
4x.
4x plus 1 times
You
x
combine the
2.
x and the x.
In parentheses, yes.
Are you thinking of combining them? We can combine them. So that'd be, oops,
That'd be
4x cubed, because the x's combine, and then x squared. We could do it like that.
Plus x.
Dan?
What happened to the 1?
Can we put the 4x plus 1, can we put the x squared in parentheses too?
Yes, you can. The x squared can be in parentheses. All right, so that was outside. If I do inside times inside, I could have that x times all that other stuff. 3x squared plus 2. Then we could distribute 3x cubed plus a 2x. Now, some of you will want to leave it like that. It is not simplified as is. Is there anything I can cancel out from every single term?
The 2
No, there isn't a 2 everywhere, Riley.
x.
There is a extra x everywhere. So I can cancel out one x from everywhere. So that'll be 4x squared, just an x, a 3x squared, and a 2. And the reason this is canceling out is because it's canceling out top and bottom. Just like we saw with the units. Because it's top and bottom, we can cancel them out because they go to 1. So this would be your simplified answer. Okay. How do we feel with this?
But
Okay, because I have one last thing, but it's not too hard. Can I erase?
yeah. Do we have to place it?
Yep, every time.
Can I have a piece of paper?
Yeah, go get more.
Oh, wait, never mind.
All right, start copying this down.
Kayla, you have this one?
Right, no problem. Wasting our time. And you have this written.
Yes, I do.
So if all the members of one set are also members of a second set, then the first set can be called a subset of the second set. Long definition for a fairly simple concept. Isaac.
What is this?
So a set is essentially a collection. So let's say all the students at this school is a set, because it's a collection of students, right? Then the 8th grade class could be considered a subset of that first set, because it's contained within. And then you all could be a subset of the 8th grade class, because you're contained within the 8th grade class.
And then I'm a subset of.
And then you individually are a subset of this actual class.
So we're a subset.
Subset.
Yeah, it's just you're saying that you are a part of something else. Okay? So let's say we're talking about the two sets, the mammals, all mammals, and then all vertebrates. Vertebrates meaning they have a vertebra, a backbone. Hopefully you learned about that at some point during science. Okay. Which one is the subset of the other? Which one is contained within the other? Jasmine.
Vertebrates?
Vertebrates is the subset of mammals?
Yes.
We agree?
No.
Riley?
Mammals is the subset of vertebrates.
Do we agree with that?
Yeah.
What do we think?
Yeah.
Yeah, because vertebrates came first.
So there are all mammals are vertebrates, but not all vertebrates are mammals. So there's a specific way that we show this. Let me make sure I'm doing it the right way.
Hey, are you recording?
Every time. Shh. So it's like a sideways U.
I see.
It's supposed to be more like, I'm just not very good at drawing it. It's like a sideways U.
Can you draw you?
No.
It has to be sideways.
Because it has to be sideways.
Tilt your paper sideways.
Tilt your paper sideways and draw a U. Sure. So the way this could be read is mammals is a subset of vertebrates. Dan, pay attention. So it's kind of like the alligator guy. Remember that guy where you read it as 5
Yeah.
is less than 7? You kind of read it the same way. Mammals is a subset of vertebrates.
It looks more like a fruit.
Okay, whatever gets you through the night. So let's say we had the set of A, which is 1 and 2, and another set of numbers, which is 1, 2, and 3.
Oh, that could be that B is inside of A.
Jared, which one is a subset? B is inside A. You can fit all of these numbers inside A. A is the subset of B. So we could do A is a subset of B. Because all of those numbers are inside B. A is contained within B. All right, there's some technical terms. I don't know how much are really going to come up in high school, so I had to even look them up just to reteach this class because I haven't used them at all. But whatever, let's get them down in your notes in case it comes up.
These like in your daily life.
No, like not at all. But if they throw this at you on the test, I don't want you to not know what that means.
Okay.
So, let me think.
What?
Let me erase the stuff at the top. Can I erase the stuff at the top?
Yeah.
Okay. Alright, shh. Stay with me so we can get out of here on time. So a proper subset is if the exact numbers in the exact order are part of the other sets. So not only is A a subset of B, A is a proper subset of B because they have the exact numbers in the exact same order.
Wait, does it matter the order?
It does, because what if I had C, the set of C being 2 and 1? Can C be contained within B? Yeah. So C is a subset of B, but it's an improper subset because the order is not the same.
Oh. But it would still be a subset of.
Mm-hmm. It's still a subset. So if you need to remind yourself, B would be the proper subset, C is an improper subset, but it's still a subset. Was it Heath?
He was like,
It's really early.
it was some kind of janitor.
Yeah, it's probably Heath.
Why did you pass it?
So what if I had another set of numbers that we call D, and it's 1, 2, 3?
It's the same thing as the.
It's the same thing. So not only can we say it's a subset, because it's not really a subset, it doesn't only contain some of the numbers, it contains all of the numbers. So D we could call an equal set. This is the last thing. Well, technically one more thing, but then last thing. It won't take long. And I don't know when you'd see it, but if you ever see the subset sign with a slash, it means it's not a subset. So like you could say that D is not a subset of C, because it's not. So pretty much in math, anytime you put a slash or something, it means not. Not equal to,
It's an improper.
not, yeah, like not greater than, I'm trying to think of other things. Whatever. Alright, that's actually it. So I'm going to be passing out the quiz for this week.